Hi everyone, thank you so much for stopping by this channel. I hope you all are doing good. Today we'll be doing some problems on Z transform. I have an Facebook page, Facebook group as well as an Instagram account where I will be I will be uploading solved problems as well as notes. So I am linking that in the description box down below. If you are interested, please go and look at the account, and if you like it, please follow it. So without further ado, we'll do the questions. The questions will be appearing in the screen. Please pause the video to read the question or write it. So we can start with the 19th question. The Z transform of a sequence x of n is given by x of z equal to log 1 plus z raised to minus 1 with ROCE modulus of z greater than 1. The value of x of n for n is equal to 1 is given by. So we have to find out the value of x of n. That is our inverse Fourier Laplace transform is asked here. Sorry, inverse Z transform is asked here. Okay. So our x of z equal to log 1 plus z raised to minus 1, right? So if I take the whenever this kind of a log things come, it is advisable to take the differentiation, because log of x is actually 1 by x, so it will be very easy for us to solve it. Okay, so we are going to take the differentiation on both the sides, that is d by dz of x of z equal to 1 by 1 plus z raised to minus 1 into this chain rule. According to chain rule, we have to take the inverse, that is the differentiation of this particular thing too. So we will get is equal to minus z raised to minus 2. Okay. So z into d by dz of x of z equal to, we are doing this because to use the property of Z transform, where n into x of n have an Z transform for minus z into d by dz of x of z. So if we have an z here, we can actually take it back, right, into x of n form. So for that reason, I am going to multiply minus z on both sides. So we'll get z raised to minus 1 after multiply minus z on both sides. Okay. So z raised to minus 1 divided by 1 plus z raised to minus 1. Take here. We can take the LCM over here. We'll get 1 by z divided by 1 plus 1 by z. So that will be equal to 1 divided by z plus 1. Okay. So the inverse Fourier transform, that is minus z into d by dz of x of z equal to 1 divided by z plus 1. Now we have to find out the inverse z transform on both the sides. So this will be equal to this only. So we'll get n into x of n equal to inverse z transform of 1 divided by z plus 1. This is not in the standard form, as we know the z transform. So I am going to take it in the, to get it in the standard form, we have to multiply that with z and z raised to minus 1, because instead of 1 I am going to write z into z raised to minus 1. Okay, then only we can get the answer. So z raised to minus 1 into inverse z transform of z raised to minus 1 z divided by z plus 1. So taking this only, this the z transform of this particular thing is actually equal to minus 1 the whole raised to n u of n. Okay, but u of n minus 1 actually, I'm sorry. Okay, minus 1 the whole raised to n u of n. Okay, so it is multiplied by z raised to minus 1. When does the z transform is multiplied by z raised to minus 1? Whenever there is a shift to the right side by 1. So the actual z transform of these two, actual inverse z transform of these two is minus 1 the whole raised to n minus 1 u of n minus 1, right? So I can write x into n, x of n equal to minus 1 the whole raised to n minus 1 u of n minus 1. So from here x of n equal to minus 1 the whole raised to n minus 1 u of n minus 1 divided by n. From here it is asked in the question to find out x of 1, right? When n is equal to 1, that is minus 1 the whole raised to 0 u of 0 divided by 1, which is equal to 1 only. What is u of 0? It is equal to 1. So answer will be equal to 1. Okay. Okay. The inverse is a transform of, I have to find out I is a t of 2z divided by 2z minus 1 the whole square. Okay. So the z transform is given here. Let it be x of z. We have to find out x of n. Okay. So x of z equal to 2z divided by 2z minus 1 the whole square. Taking these 4 outside, and I have to leave this z alone. Okay, so that I'll take 4 outside, that is 2 outside, and its square becomes 4. That's all. That is z minus 1 by 2 the whole square is coming here. That is 1 by 2 in z divided by z minus 0.5 whole square. Okay. Now the question arises, when will this z square, that is z divided by z minus 0.5 the whole square arises. So we are going to do the simplification here. This is a very important place. Please keep attention. So a raised to n u of n, we know the z transform is z divided by z minus a, right? So if it is multiplied by an n, then what will happen is minus z into d by dz of, let this be g of z. Okay, g of z will happen, right? So this is applying the z transform property. So minus z into d by dz of z divided by z minus a will come. I'll see what will be the answer. Into d by dz of z minus a into 1 minus z into z minus a is 1. Okay, z minus a the whole square, right? And simplifying, we'll get minus z whole divided by z minus a the whole square, which is equal to a z divided by z minus a the whole square. Okay, so please keep this in mind, that is n into a raised to n u of n will give us a z divided by z minus a the whole square. This is a very important conclusion. So now coming back to the question, here it is given x of z equal to 0.5 z divided by z minus 0.5 the whole square. If I am taking the inverse z transform, x of n will be, this is resembling this, right? A z divided by z minus a the whole square. What was this inverse for here? Z transform n into a raised to n u of n. So x of n will be n into 0.5 the whole raised to n u of n. Okay, that's all. So instead of 0.5 we can write 1 by 2 also.